We're looking today at price elasticity of demand. We usually refer to that in economics as PED. And what the term means, think of elasticity like how much something can stretch. So we're saying how much demand stretches or changes due to a change in price. So we're asking or we're answering the question, how does a change in price affect quantity demanded? We'll see that the same change in price, maybe from $2 to $3, will affect different products differently. Or we'll also see that if we look in percentages, a 10% change of price can affect the same product differently depending on if we're going from like $1 to $1.10, or if we're going from $10 to $11. Both of those are a 10% change in price, but obviously because one is only a change of 10 cents and the other is a change of $1, they're going to have different results. That gets us to this point that you need to understand that when we talk about price elasticity of demand, we're not going to talk in absolute terms, we're always going to talk in percent terms. The reason for that is price elasticity of demand is very connected to total revenue and trying to maximize total revenue. And it's just more useful to talk in percentages when you do that. So, as an example, think if you had Cokes and Corvettes, and if we just looked in absolute terms of raising the price of each of those by $1. So you go in to buy a Coke and you thought it was going to be $1, but instead it's $2. Versus you go to buy a Corvette and you thought it was going to be $70,000 and it's $70,001. Well, we can assume that there would be very different results on the quantity demanded for the two products. Some people, maybe not a lot, but some people would say, you know what, I'm not going to pay twice the price for a Coke that I thought I was gonna pay. But if you were planning on buying a Corvette for $70,000, it's pretty silly to suggest that very many people at all, probably nobody, would go, well, I'm not going to pay $1 more. It just seems a little bit hard to accept. So some of you might be thinking, well, wait a minute, Cokes and Corvettes are very different products. You're right, and stay tuned for when we talk about determinants of PED. That is, why are products different in terms of elasticity. For our example today, we're going to use this formula that we've seen before, which is QD equals 400 minus 8P. Now remember, 8 here is an absolute term. It's saying every time I change price by 1, quantity demanded decreases by 8. Well, we'll see in a second, that's fine and good, but it has nothing to do with price elasticity of demand because we're going to be working with percentages. Let's see an example. So these numbers are all derived from this formula. You can put it on pause and check me if you want. The first price is a price change of 5 to 10. So again, we're 400 minus 8 times 5. So 8 times 5 is 40. So 400 minus 40 is 360, so on and so forth. I'm not going to do the rest of those. I trust you know how to do this at this point. When we look at changing price from 5 to 10, in absolute terms, we raise the price by $5. But in percent terms, we doubled the price. We changed the price by $5. The original price was 5, so it's 100% bigger. If I take the same change of 5 and put it further up the demand curve, well, if we go from 25 to 30, now that same absolute change of 5 is only a 20% change in price. And that's an important difference. At the same time, because we're 5 times 8, we're going to see demand drop by 40 here, 360 to 320, and 40 here, 200 to 160. In absolute terms, it's a change of 40%. Of 40. In percent terms, it's a change of 11% or 20%. So again, in absolute terms, the change is the same whether we look at the first or second example, but we see that the percentage of price decreased and the percent change in quantity demanded increased. And that's really, that difference is the important part of what we're looking at. Ultimately, we're looking at an issue of proportionality. My example is, say I give you two assessments all year long. One is a 10-point quiz and you get half of the questions wrong, so you get a 50%. The other is a 100-point test and you get 10% of the questions wrong, so you get a 90%. And what if I just average those two? 90 plus 50 is 140, divided by 2, you get 70%. I don't think most people would be very happy with that. And again, because it's an issue of proportionality, you would say, well, wait a minute, the one quiz was really small, so me doing badly on that shouldn't have that much of an effect on my grade. The test was much bigger and I did well on it, so that's more indicative of what I know and my skills in the course. And I would agree with you, you're right. So it's an issue of proportionality. Let's say that we have a price change of 10%. And what we want to see is the change in quantity demanded proportional, less than proportional, or more than proportional? So let's start here with the blue one. If I change price by 10% and quantity demanded also changes by 10%, now remember, it's still the demand curve. We're saying it's going to be 10% lower. If price goes up 10%, quantity demanded has to fall 10%, and vice versa. But if it's a 10% change in price and a 10% change in quantity demanded, that's a proportional change, and we have a term for that. We call it unit elastic. If it's the same 10% change in price and our quantity demanded now changes by 20%, that's greater than proportional, and our term for that is elastic. If it's less than proportional, so 10% versus 5%, our term for that is inelastic. Our formula for PED is shown right here. So PED is calculated by dividing the percent change in quantity demanded by the percent change of price. And very simply, we can see if we take these numbers, if we take a big number like 20 over a smaller number like 10, so big over small, well, that's going to produce a PED value that's greater than 1. In this case, it would be 2. 20% divided by 10%, 2. If we have 10% over 10%, so quantity demanded over percent change of price, so 10% over 10%, well, that's the same number over the same number. That's also a shout out to those of you who have been to Thailand. And obviously that's going to be proportional, or 1. So again, 1 here represents proportionality. So greater than 1 is more than proportional, less than 1 is less than proportional. And that happens when we have a small number divided by a bigger number, like 5 divided by 10. We can also see that on a number line real easily. So if we look, all of our values between 0 and 1, those are going to be our inelastic values. 1, of course, is our unit elastic value. It's really more of a reference point than anything else. And then greater than 1, these are going to be all of our elastic values. Let's look real quickly. Let's look at what we did before and see what we can find out. So if we go from price of 5 to 10, let's see what the PED is going to be. Well, remember, it's percent change in quantity demanded, that's here, over percent change of price, and that's here. Now, I don't need you guys to actually go figure it out. It's enough to say for now, it's a smaller number over a larger number. So this is going to be small over a big number. This is going to be an inelastic change, what we see with this first example. With the second example, well, now we see the percent change in quantity demanded, 20%, is the same as the percent change in price. I didn't actually try to do that, but that's what the math did, so it works for me. Anyway, and that's going to be a unit elastic change. Now we're going to see how elasticity can be shown on a diagram and try to make it a bit more important, or at least more relevant to what we're learning. We're going to use the same formula, and we're going to go from 30 up to a price of 40. And we show that here. So the first thing we need to do is we need to calculate the percent change in quantity demanded. We can do that in a couple of ways. We're going to go on with the more basic way now. So the percent change in quantity demanded, we look at the new number, so we're going from 30 to 40, so we're going from 160 to 80. So we're going from the new number, 80. We subtract the old number, 160, and then divide by the old number, which is 160. So I can see real easily, and again, I had 160 and now I have 80. I think most people can see that I cut that in half, so I lost 50% of my quantity demanded. So this is going to be 50%. For our price, again, I know a lot of you guys can already see it. You can go, okay, well, I went from 30 to 40, so price increased by 33%. But let's prove it. So new number, new price, minus the old price. So 40 minus 30 divided by the old price. So 40 minus 30 is 10 over 30, and that's going to be 33%. So our PED value here, clearly we can see that it's going to be greater than 1, whatever it is. I suppose it's about 1.2 or somewhere around there. No, closer to 1.5. Anyhow, we can solve that out. The point is that it's greater than 1. So let's see what the effect is going to be. Well, if you look back a couple of videos, we were looking at total revenue. And that's the first thing that you have to understand when we talk about price elasticity of demand, is the effect on total revenue. If you remember, we said that total revenue is maximized at this point, which is the midpoint, and that's 25. So this change from 30 to 40 took me away from that middle point of the demand curve. So let's go ahead and see what happened. We've got our boxes here. We've got A, B, and C. No matter which price I have, I get to keep box B. But let's go ahead and see the value of that anyway. It's 0 to 30 times a run of 80. So that's 30 times 80, 2400. Box A is 30 to 40, so a rise of 10 times 80, and that's 800. And box C is 2400. So this makes sense. It's pretty easy to see visually that C is bigger than A. So if I move from 30 to 40, I give up C to get A. C is bigger, so I want to keep it, both in area, visually, but also if I look at 2400 versus 800. And 2400 minus 800 is 1600. That's how much my total revenue would change by. So this would be a bad idea if I'm trying to raise revenue. On the other hand, if we went from 20 to 25, let's see what that's going to look like. So now what we notice is that we're going from a point on the lower half of the demand curve up towards the midpoint. In fact, we're ending up at the midpoint. So let's see what's going to happen here. This is our new quantity, 200, and our old quantity, 240. So it's 200 minus 240 over 240. So this is going to come out to be 1/6. In price, here's our new number and our old number. So this is going to be 20 minus 25 over, sorry, I switched those. 25 minus 20 over 20, and that's going to be 1/4. So now I've got 1/6 over 1/4, and I can see this is going to be less than 1. It's going to be an inelastic value. 1/6 is about, 0.16, and 1/4 is 0.25. So we have the smaller number 1/6 on top of the larger number. Remember, with fractions, it's easy to switch that up because 6 looks like a bigger number than 4, but 1/6 is smaller than 1/4. So this is going to be an inelastic value. So I can predict that as I move up in an inelastic value, that total revenue is going to box that we get to keep, that's box B. It's worth 20 times 200, so that's 4,000. This box is 5 times 200, so that's 1,000. And then this box is 20 times 40, a run of 40 up 20, so that's 800. So this looks like a good deal, or a better deal if I'm trying to raise total revenue. I'm giving up 800 to get 1,000. Well, obviously that's going to have a positive effect on my total revenue.